sampling is done for specific purposes, there are some factors affecting the choice of sampling plan. The purpose of inspection, nature of the product, nature of the test method, and nature of the population being investigated. Those are the most important 4 factors what we have to think before we decide the sampling plan. So now you are having some idea about the sampling plan, that is how we are going to collect the sample. So that is most important. So accordingly we are going to prepare we are going to design our experiments, right? So let's go one by one about the purpose of first we can discuss about the purpose of inspection. So what is the purpose of inspection? So have you remember that in the first day lecture or the second day lecture we have this list out? So why we are going to do the analysis? So what is the purpose of food analysis, or the what is the purpose of doing testing of different kind of foods? Have you remember that? You have discussed about the for you mentioned about the to include the nutritional in the packaging material for the nutritional composition, or sometimes we are going to analyze what is there in the for deep analysis to identify the compounds, or sometimes we have to give the accepting it or rejecting it. Likewise, so you have listed a lot of things. I think more than 6 or 7 we have discussed about. These are the points why we need to analyze the sample. Accordingly, that the purpose of inspection is the number 1. So especially in the food industry, or sometimes especially in the laboratory situation, for your research project, sometimes we are not going to check for accept or reject. We want to collect the information to provide to go for a conclusion. We need our data. But in the case of food industry, basically, so we have to decide why we are going to do this analysis. I mentioned you, is it to accept or reject the lot, right? So I have explained you that regarding that the Kiel's sausage sample, we have analyzed during the initial stage of corona in this second wave, because to accept or reject, or whether before they are going to release the sample to the to the consumer or to the market, they have to analyze the sample for salmonella and some microbiological testings we have to do. If not so, we can't say that our product is very safe for consumption. Therefore, we have to analyze it for that purposes, right? In some situation, before you get the milk or the milk bowsers or the milk what need for a company, we have to test the milk for the adulteration at the receiving point. So therefore, at that point, so we have here if the milk is adulterated, we are going to reject it. We are not going to accept it, right? And also the same thing will be happen at the milk collection centers. When the farmer bring the sample to their milk, their harvest to the But in the case of, think about that, sometimes you may have seen that how the tea factories are functioning. That time all the tea is coming to the tea, people who plug the tea, and then the tea leaves, and then it brings to the collecting centers. And after that, they get the sample, and then they dispatch it to the processing companies, manufacturing place, tea manufacturing industry, but the factory. But that time they are not going to reject, right? What they do is they accept, they check actually how they check. Sometimes they check by the leaves, how they pluck the leaves, whether there's a 3 leaves or the 4 leaves or whatever, whether they have produced the tea leaves in whatever the required quality. If so, they are not going to reject that sample. They check the sample, but they do not reject, they accept it. that time, because it doesn't matter, right? So the purpose of inspection is not a rejection. Sometimes they may give a low price for the people, but however they accept, right? So therefore, what the purpose of the inspection is very important. So if the case of, you think about the Maliban or Munchie, that if the biscuit is roasted a lot, it's so they, after doing the sensor analysis, they are going to reject the sample. They are not going to release that sample to the consumption or the market, right? Likewise, so there are a lot of example you can get thinking about the situation. So this is is it to accept or reject the lot. Then the next one is testing milk co-adulteration at the receiving point. Is it to measure the average quality? So sometimes, as I mentioned you, in the tea leaf situation, they measure the average quality, or the random inspection of product after producing. This is the average quality. Sometimes they check so especially in the case of what is in the biscuit even. So if they see that it's over roasted, then they reject it, right? They reject, or that means they are not going to produce or give it to the company, market. And they measure the average quality. Random inspection of products after producing is doing for this purpose. Actually, when the production line is going on, then that time they randomly select the sample and send it to the food analysis laboratory, and then the people who food analysts are there, they analyze the sample and they send the report to the again back to the production line. Then or sometimes they send it to the final product releasing point. Accordingly, they release the product or not, right? So is it the product is going on, as I mentioned, you test for LCT of food use with reference to identify deviation. They have the reference list, so they check the production is going on. They check sample time to time. At that time, if there are some deviation, they want to check the deviation only. Then after they identify the deviation, they make up it and send the sample. If the acidity is high, then they do they take precaution to reduce the acidity. Or if likewise, especially in the flavors or the colors, at that time they do some adding natural flavors or natural colors. Then they will be able to make the correction. So therefore, the purpose of inspection is important. Then we have to think about the nature of the product. So what is the nature of product? Is it homogeneous or heterogeneous sample? What is the unit size? How consistently have past population met specification? What is the cost of the material being sampled? If cost is very high, large samples cannot be used for analysis. So this point I have explained you earlier, the nature of the product, right? So the unit size is really important in this case. That is, especially I mentioned you about the canned fish containers or the dal containers, or the lot of products come to the country. We import, right? And that time, so what is the unit size? Accordingly, we will decide how we collect the sample, right? Then the nature of the test method. Is the test is critical or minor? So we are analyze this thing. Just a moment. So nature of the test method. Is the test critical or minor? Is the test method hazardous? Is the test destructive or non-destructive? Or how much does test cost to company? So this information, nature of test method is very important, right? So here that I think that the test method destructive or non-destructive. What is the meaning of destructive or non-destructive? So that is important to find out. So how we can explain that the destructive test method and non-destructive test method? That the non-destructive testing, especially, so how we can get the example, is a wide group of analysis techniques used in science and technology industry to evaluate the properties of material component or system without causing damage, right? The term non-destructive examination is are also commonly used to describe the technique, right? Then what is the destructive one? If we go for a destructive testing methods, says that it's carried out to a specimen's failure in order to understand a specimen's performance or material behavior under different loads, right? So here the non-destructive one, especially we are using for is the test destructive or non-destructive? That means so whether the method we can use for this one or whether we can't use this method for this for the testing. So the nature of the test methods, because sometimes if we are going to analyze, we can use different method for the testing, right? So we can use different method for the testing, but some methods are suitable for analyzing that sample, but same method is not suitable for the other sample analysis. For example, let's see now the oil is now we want to analyze the acidity of the sample, right? So if the sample is oil based sample, that sample is not dissolved in the normal aqueous medium because it's a non-polar sample. Therefore, it is not dissolved in the polar medium or the aqueous medium. Therefore, in such situation, we can't use the same method to analyze the acidity of the oil sample, right? In the other case, now if the case of you think that the lime juice sample, so if we want to measure the acidity of the lime juice sample, it is a polar. Therefore, we will be able to use the aqueous system to analyze the sample. Especially in the previous case, what we do is in that case, for the lime sample, we can dilute it by water. But in the case of oil sample, then what we do is we use the ethanol and the chloroform, and then we then we dilute it with the ethanol, because ethanol is polar and chloroform is non-polar. First we dissolve the chloroform a little, then add the ethanol. After that we can use the same analysis, or the sodium hydroxide or the whatever the base medium to titrate the sample. So likewise, so we have to decide that whether the test method is destructive or non-destructive. Accordingly, we have to decide the test method, right? Nature of the test method is very much important. For example, sometimes if the liquid sample is not suitable for analysis in the we can't analyze the same way the gas sample. Gas and liquid is different, right? Sometimes the high viscosity. High viscosity means if the thickness is the increase the sample or the high, then we can't use the same method for the low viscosity sample. So likewise, so nature of the test method is important, whether we can analyze the same sample or not the same sample, different sample by using the same method. Therefore, the test critical low minor, test method is hazardous, is the test is destructive or non-destructive. That means universally can we use this sample, use this thing for analyze that one. For example, let's say if we want to measure the weight of the sample, yes, we can use that we can measure by using the balance weight of the sample. Yes. So if it is liquid, yes, we can, because we can trap it. So we can use the beaker or whatever the container. First we take the measurement of the container, after that we put the liquid, then get the difference of the weight. So therefore in that the weight to determine the weight, then it's okay. But sometimes it's according to the different weights, maybe 5 grams, 1 gram, 0.5 gram, or the 0.1 gram, or the 100 gram, 1 kilo. In such situation, you have to change the analytical balance, but not the test method. So the weighing gravimetry method is okay, universal. So how the last point is how much does test cost to company? That is important. Actually in our case, even if we don't have the facilities to analyze the sample, then we want to send the sample for other companies or the testing companies. In that time, we actually search the prices of many companies and see which company price is lowest, then we will send our sample to that company to get the analysis. If not, so company also should have to check about the costing. That is why most of the companies, they do have their own laboratories and do small tests at the company quality assurance lab, as sometimes maybe 1 month time, 2 months time, or likewise for some testing only they send the sample to the other the testing company, right? And right. Next point is nature of population being investigated. So is the lot large but uniform? Does the lot consist of smaller, easily identifiable sublots? Or what is the distribution of units within the population? So nature of population being investigated is the last point. So is the lot large but uniform, right? If it is a large but uniform, then wherever the place you can take the sample. So therefore it won't be a problem. But if the lot is large but it is not uniform, then it will be a problem. You have to think about the different method to make it uniform, and then you can take the sample. Does the lots consisted of smaller or easily identifiable sublots? So it is there's a lot consisted of smaller or easily identifiable sublots. So it is much better, because if the sample is big, but there are some easily identifiable sublots. So in such situation, what we have to do is we have to take the sublots only, right? So how we can what kind of example we can get for a second point? Does the lot consisted of smaller or easily identifiable sublots? Now think about that the fish. These days the corona is a problem. Therefore, the people are not going to eat fish, right? Because coronavirus is not inside the fishes, but the thing is the handling procedures, handling practices of the people are really poor. So that is why they are in the surface of the fish, and it can grow very faster, and therefore they is spreading the people who are handling the fish in the same at the home level or the market or the likewise, right? So here in such situation, so identifiable sublots are not there, because we can't say that this fish is having such a load of coronavirus, so the other fish is having such a small amount of coronavirus. So the identifiable sublots are not there, right? But we want to analyze the sample for the corona, whether the fish is having the coronavirus. Identifiable sublots are very limited. But in the other case, even now, you see now the corona is now virus is spreaded in the Sri Lanka in a lot of places, but identifiable sublots are not there. Therefore, what they do is they close the lockdown the western province or likewise. But I think the situation is going to bad in near next few weeks even, because identifiable sublots are not available, because people are not telling that they are having cough or they are having the what's here flu, or they are not telling anything. So therefore, does the lot consist of smaller or easily identifiable sublots? So that situation there is not such kind of sublots, right? Now I think you have heard that the bread sellers are going nearby my house, and so I know that in your area also that the bread sellers are there. Then you want to analyze the salmonella contamination of the not the salmonella. Let's see, salmonella is not there. However, we want to analyze the sample for what kind, what is for a protein content, right? So in that case, so there are the bread are there, buns are there, the rolls are there. Likewise, lot of different categories they sell. In such situation, if you want to take the sample for all the categories what the person is selling, in that situation we can take the from the few breads or few buns or few the other whatever the rolls or other fish bun or likewise, or different subcategories or sublots we can identify very easily. But there are the sublots also there as a whole bakery van, bakery item selling van, but sublots also there, right? So it's easy. But here that the here it says that the sublot sometimes as a uniform sample sublot. Then it is for a canned fish or the sometimes the biscuit manufacturing company. So the some yogurt company or the some cheese company likewise. So different sublots you can identify. So it is a lot consisted of smaller or easy identified sublot. Then it must be much easier to get the sample. What is the distribution of units within the population is also very much important. Distribution of units within this population is also important, that in case of the corona case, the distribution of units within the population we can't identify. So it is a really problem to identify the subunits, right, or the units within the population. But it's a population, I mean the whole population in Sri Lanka. But in the here the population is our bigger sample. So that situation, so the distribution of units within the population is we have to identify, and then we can drug the or take the sample for our investigation. So nature of the population is being investigated is most important. Now let's go for a sampling plan. So this is bit sometimes it's a bit confusing, but sometimes it can be easily understand. It's up to you, because you have to do concentrate this point, as well as you have to ask any question if you can't understand what I am telling. Here there are three types of sampling plans: single sampling plan, double sampling plan, multiple sampling plan, right? The single, double and multiple. What is a single sampling plan? Selection of the sampling plan type which depends on the expected overall lot quality and sampling cost, right? Selection of the sampling plan type which depends on the expected overall lot quality and the sampling cost. This allows accept or reject decision to be made by inspection of one sample specified size. For example, now here we are going to tell our results thinking or the considering about the whole lot, overall lot, right? We are going to get the sample to analyze. Here single sampling plan, get the sample to analyze, and finally whatever the results we are getting, we will use it to tell about whole sample. For example, likewise, now you know that Now you know that, so think about the adulteration test of the milk, right? In that situation, we are going to, because this is the acceptance or rejection test. If the sample, the milk sample milk is adulterated, we are not going to use it. Therefore, but we are not going to analyze whole population. මුළු බවුසරකම අපි analyze කරන්නේ නැහැ. බවුසරකේම තියෙන testing කරන්නේ නැහැ. But we are getting the sample and at the collection milk collection center or at the company level, company receiving gate. So we analyze a small portion, maybe the 10 ml or the 10 ml, but adulteration is unique for all the lot means all Bowser or the full sample, and therefore if it is adulterated, we reject the sample, reject the lot. Therefore, they are single sampling pan, very easy. Acceptance or rejection only do the decision here, right? For example, moisture determination, different cost, electricity, labor, and equipment. So here, this allows accept or reject decision to be made by inspection of one sample specified size. The moisture determination electricity, labor. Here, actually, I want to tell that the moisture determination is not a rejection. We are not going to reject the sample because of the moisture determination. So normally, we use the moisture determination by using different methods, right? You have seen that today morning we have given the assignment for you. Not today. Today you have analyzed the fat content. Previous day, the moisture determination, we have done different methods for different type of sample. For the dry sample or the wet sample or the liquid sample, there the moisture determination, the wet sample moisture determination is not doing for the liquid sample, but however the wet sample is different. So high oily sample, high volatile sample moisture determination is doing different way, right? Here but this moisture determination is actually not accepting or rejection level in the most of the situation. But at the receiving point, that for example, let's say now the moisture determination is doing for a fish. So that situation, we are not going to reject the sample because we want to know the moisture content of the fish for some other purposes. So if not so, if we want to analyze the sample for other different parameters, for that purpose, we need to know what is the moisture content of the sample. So likewise, for example, let's say now we are going to analyze the proximate composition. Here we want to analyze moisture, protein, carbohydrate, and fat, right? And also we do the ash. But in the situation, normally we do not analyze for the carbohydrate, but what we do is we analyze the sample for other components and then reduce from the whole component and calculate the carbohydrate content. So that is the way of carbohydrate determination. Not the determination, actually carbohydrate we do calculation. In that case, we want to analyze the moisture content of the sample, right? So likewise, so later on you can understand this much clear. But if you want to, if you can't understand now, then let me know. Then I will explain you by using different examples. So, however, this allows accept or reject decision to be made by inspection of one sample specified size. And also the other situation, the different costs are incurred in this situation. And sometimes the electricity is needed, labor is needed, the equipment is needed. In such situation, because of this situation, we are not going to analyze lot of sample. Only few samples we analyze then, but we give the results considering whole lot. So in other case, what are the examples of application? Intake of raw material, poultry is tested for presence of salmonella species, right? So here what we do is we want to check now the chicken samples are coming from the company, let's say Baira company, if the chicken samples are going to release at that time, so they are not going to check each and every chick. What they do is they randomly take the sample and check for the salmonella, and if the salmonella is positive, then they are not releasing the sample, and they backward their sample. They are not going to put it to the company. In the keels I mentioned the sausage sample, they randomly take the sample and analyze. If the salmonella is positive, they are not going to release the sample for the market. That means this is the acceptance or rejection test. If the salmonella is free, they accept the sample and they release it to the market. If not, they are not releasing the sample, right? Other example is quality and safety confirmation of products. Canned foods are tested for Clostridium botulinum. That is also the same. But in that situation, let's say now you are going to check the sample for a canned fish for Clostridium botulinum, or the jam. Jam is not there. The Clostridium botulinum is not in the jam, but many meat or the different types of canned fishes are canned foods are there. So if the Clostridium botulinum is positive, then they reject all the lot. If not so, not only that can or that bottle or not like that. Therefore, the quality and safety confirmation of products also we use this simple sampling plan. Out of a batch, consignment sample can be taken. It can be homogenized and tested. If sample doesn't match with agreed parameters, reject the whole lot. So that will be happen normally in the customs. So especially when we import the food sample. Then we can explain it very easily in that way. Single sample acceptance with fault rectification. Lot of a product is let's say capital N, M units are sampled, right? Out in the lot of a product N. So the product N is there. The number of products are N. Out of that, we take M units are sample. Then if there is a 0 defects in the sample, then we go forward. Yes, lot is accepted. If there are 0 defects, no, more than there are some defects. In such situation, lot is rejected. 100% inspected, non-conforming units are replaced, right? That here in that situation, sometimes especially this situation is going on especially in the company, the production lines. If there are defects are there, what they do is 100% lot is rejected, and then they again inspect the sample, and they inspect the sample and they check what sample are having defects, and what product is having defects, what product is not having defects in that situation. So they are taking that one and rejecting other one. It can be happen not for a food sample, but in the case of food sample, they can't. But in some situation, let's say now, it's the packaging material. If you are going to pack in the vacuum packaging, you have seen that nowadays, so at your home even, that there are a lot of packed products are coming, right? So in that situation, actually before the company release the packed products, they check randomly. If they found some defect, what they do is they reject all the one, and then they check each and every lots, and finally they can identify what are the sample, what packages are having defects. If that situation is okay, but however, they have to later on they have to take the precaution, because defects are going on. Therefore, they have to rearrange the situation, and not defects should be there. And accordingly, they have to rearrange the situation of the production line, and they have to take precaution to not to happen this defecting situation, right? So this is the single sampling acceptance with fault rectification. So it is not so difficult, this situation. When we come to the double sampling plan, this refers selection of two sample sets. What the thing they do here is they take two sample sets After analyzing first set of sample, they accept or reject can be decided according to the high-low quality. If the analyzed sample shows intermediate quality, then the second sample is analyzed. Now here actually, now in the case of Salmonella, actually it's a single sampling plan, because if Salmonella is positive, they reject the sample. But let's say now the total bacteria count is not. Therefore, if it is coming to the rejection, second sample also can be, if it is in the, go for a third sample, and then they can decide by, yeah, actually they are not. Right? Here, if the analyzed sample shows intermediate quality, then the second sample is analyzed. Then the second sample is okay, then they accept the sample, or accept the lot. If not, they reject the lot. So let's see more about this. Select the first sample of size. So it is in one size, and count the number of defects D1 during the time T0. At the time, what are the defects are there? They count it, and after that, then they go forward, and the D1 is defectives at the time 0, less than C1, and greater than C2. That means C mean here the count, number of the defects, right? Defects is D1, count the number of defectives D1 during time T0. If so, control 1 or the what is if it is a rejection level, if it's C1, then D1 represent the in between C1 and C2, then they go to the select a second sample of size N2 and count the number of defectives D2. In that situation, they check if D1 and D2 greater than C2, right? D2 is greater than C2, they reject the lot, because the decision is defectives should be less than this number, C2 number. Defectives should less than C2 number, and if it is more than C2, what they do is D1 plus D2 is greater than C2, they reject the lot, and D1 plus D2 is less than C2, they accept the lot. And here also, then they come here, they come to the left hand side, you can see accept the lot. D1 less than or equal C1, they accept the lot. And other one is D1 greater than C2, they reject the lot, right? Therefore, the C1 is the smaller size, and the C2 is the bigger size. The defectives they count, and if it is in the between, that it should be there in between C1 and C2, but they count the numbers of defectives D2 and D1, and D1 and D2 greater than C2, they reject the lot, right? Because the D1 and D2 less than C2, they accept the lot, because they do not keep any kind of so the how we can say that කිසිම විදිහක ඒගොල්ලෝ තියාගන්නේ නැහැ එතෙන්දී chance එකක්. ඒ කියන්නේ අපි chance එකක් තියාගන්නේ නැහැ. මොකක් හරි වෙලා මොකද මෙතෙන්දී ඒ chance එකක් තියාගන්න නැත්තේ එහෙම chance එකක් තියාගෙන බැරි වෙලාව defectives වැඩි වුණොත් කියන ප්‍රශ්න ආවොත් අනිවාර්යෙන්ම ඒක reject වෙනවා මාකට් එකට ගියාම. ඒ නිසා chance එකක් තියාගන්න නැති වෙන්න තමයි මේ double sampling plan එකේදී D1 and D2 greater than C2 definitely they will reject the lot. ඒක less than නම් C2 ඒගොල්ලෝ okay chance එකක් නැහැ අපිට කොහොමත් sample accept කරන්න පුළුවන් whole lot එක C1 D1 එකට වැඩි D1 එක අඩු නම් කොහොමත් පුළුවන් හැබැයි D1 එක වැඩි නම් reject the lot මෙතනදිම එම් ඒගොල්ලෝ තව එකක් check කරලා ආයේ මේ විදිහට තව chance එකක් තියාගන්නවා right. So now you can understand. So in that the second double sampling plan, no chances after analyzing the second lot. Right. Then let's go for a multiple sampling plan. The amount of sampling depends on the overall lot quality. Now here, when the cumulative number of defects lie above the rejection line, the lot should be rejected. When number of falls below acceptable line, the lot can be accepted. Let's go to the next slide and we can see what is going on here. Multiple sampling plan. So now n and right. So here accept the lot and reject the lot. So that is the major situation in the multiple sampling plan also. Now, okay, rather than this one, I think this one is easy. I can explain you easily. So the number of defectives are there in this way, y-axis, and number of items inspected is this way. Now here rejection line is D2 equal Sn plus M2, and the accept line is D1 equal Sn plus C2. Now here you can see here the y-axis is number of defectives. If the number of defectives are increased, then definitely sample will be rejected. But the sampling continuing is going on. Here that the D1 equal Sn is Sn number of sample plus M2, right? Here defective is number of sample minus M2. Accept all sample below acceptance line, reject all samples above rejection line, and continue sample for all samples in between acceptance and rejection line. Now here they check it, and if the detectors are high, they reject sample. So this is the line. This is the first line. This is the second line, right? So if the sample is having more defects, they are not going to accept it, but they continue the sampling, right? Now here the sample is in 1 and it is less than C1, then they go to the accept the lot, right? And if the C1 is less than number of sample, and if it is here actually the R and S is not defined, no multiple ranking this situation. I think therefore the not defining R and S, it's difficult to explain, but okay, I will explain this one later on by yeah. But simply actually what is going on, that the N is the number of samples here and it's going on, and the C1 is the, as I mentioned earlier, what are the problems here, and the correctives is less than is number of sample and less than R, but R and S is not defined here. Yasara, have you remember this C1 and R1 rejection? Yeah, I will explain you this later on. Let's come to the error in measurement, right? Yasara, are you there? Seems like she is not there, right? Right. Let's come to the errors in measurement. The question is, results from 6 replicates for determination of iron in aqueous sample of a standard solution containing 20 ppm of iron is given here. Find mean and medium. So you do this analysis, you do this calculation, and let me know what is the mean and median quickly. Yeah, you analyze this one, so I will come back regarding that our other point, right? Have you note down these points quickly? Okay. So write down this 19.4, 19.5, 19.6, 19.8, 20.1, 20.3, and also the true standard solution containing 20 ppm of iron. And even we need these the values to understand the other errors. Until that, so I will check that the sample errors, sampling errors, that more detail. Okay. So I think you have found got the mean and median value. What are those? What are the values? Mean and median. 19.878 is mean and median 19.70. Mean 3. So have you all got this number 19.78 and 19.70? Give me other person also the value in chat. You can type it. Right, good. Okay, keep that. You have calculated the three digits there. 19.783 is mean. Right. Keep those value, and until shall we come that point again. And before that, so I want to explain the double sampling pen. I know that you have not got. I was not correctly explain it, right? Let's come back. Here, double sampling plan. What is double sampling plan? So here, double sampling plan, how it works. Double, and I think you can read it, right? Can you see the screen? Naveen?
Yes, madam.
Right. Let's read. Double and multiple sampling plans were invented to give a questionable lot another chance. Right? That means that if there are questionable lot, they give another chance to go forward. Forward. So that is why the double and sampling plan is important. If the simple sampling plan is a just accept or reject. There is only one answer is there. But here double sampling plan, they give a questionable lot another chance. For example, if in double sampling the results of the first sample are not conclusive, with regard, I have not come to the conclusion yet. A second sample is taken. Application of double sampling requires that the first sample of size n1 is taken at random from the large lot, right? First application of the double sampling requires that the first sample lot එක ගන්නේ n1 කියලා let's name it n1 from randomly from the large lot. The number of defectives is then counted then compared to the first sample's acceptance number A1 and rejection number R1. Denote the number of defectives in sample 1 by D1 and in sample 2 by D2 then. So we can write it like if D1 less than or equal A1 is the acceptance number. First sample's acceptance number is A1 and the lot is, if so, the lot is accepted. D1 is D1 is denote the number of defectives in sample 1 D1 and denote the second sample defectives in the sample 2 is D2. Then D1 less than A1 acceptance එකට වැඩි D1 එක අඩු නම් defectives අඩු නම් ඒක lot එක accept කරනවා. D1 එකට වැඩි R1 rejective rejection number වැඩි නම් the lot is reject කරනවා and sample is taken, right? D1 එක less than A1 accept එකට වැඩිය D1 එක ලොකුයි. හැබැයි rejection level එකට වැඩිය අඩුයි. In that situation, අපි second sample is taken. Here you can see rejection level and the acceptance level අතර තියෙනවා there is a gap. Earlier in the first single sampling band there is a no gap. Only A1 acceptance or rejection. Acceptance equal to rejection. But here the difference is acceptance and rejection. In between acceptance and rejection there is a gap. A gap එකේ අතර D1 එක වැටුනොතින් we will go for a second sample. If a second sample of size n1 is taken, then this number of defectives here we call D2 is counted. The total number of defectives is D2. Total කියන්නේ D1 and D2 දෙකම. Now this is compared to the acceptance number A2 and the rejection number R2. Then පළවෙනි level එකේ තියෙන A1 and so D1 A1 R1 is it's a one level. ඒ දෙක තියෙන්නේ පළවෙනි level එකට. ඒකෙදී අපි පාවිච්චි කරන number of sample ගන්න වෙනස්. මොකද second එකට එනකොට there is a we use the more sample. First defective වෙන එකේ එන එකයි දෙවෙනි එකේ දෙන එකයි දෙවෙනි sample lot එකේ එන එකයි දෙකේ එකතු D2. Now this is compared to the acceptance number A2. It's a accept number now A2 එක ටිකක් ලොකු number එකක් දැන් තියෙන්නේ, right? And the rejection number එක R2 ඒකත් compared to the A1 A2 is a bigger one, compared to the R1 R2 is a bigger one. In double sampling R2 equal A2 plus 1 to ensure decision on the sample. R2 is now the rejection number. No, rejection number is equal A2 කියන acceptance number plus 1. ඒකට වැඩිය ටිකක් උඩින් තමයි තියෙන්නේ. So if D2 less than A2, the lot is accepted. Then D2 greater than R2, the lot is rejected. Keep on in your mind here, D2 and D2, A2, R2, these values, capital D2, these values are bigger than the previous simple D1 and simple D2. Now, after that, actually, there is a different method. Can you understand this one? Are you all right? If you need to explain again, please let me know by using the chat. I will share this part, so I will share with you when I give the reading material regarding this one. Are you all right? That point? මේක තේරුණාද? ආයි කියලා දෙන්න double sampling plan එක. You read it by yourself then. I think up to this point you can understand, right? A1 less than D1 less than R1, acceptance. D1 here defective one, first lot of sample are taken, calculate the defectives. If the defectives are less than acceptance, greater than acceptance, then or it's lesser than rejection, then second sample is taken. But in the case of R2 in double sampling, R2 equal A2 plus 1 to ensure addition on the sample. So මෙතන ලොකු margin එකක් they do not keep the big margin here in the second situation. First situation there may be a big margin, but when they come to the second situation there is not a big margin, because there is no chance actually. If there is a small chance they have given, if the sample is still not good, still there are a lot of detectives, they will reject the sample. Have you got this point? So anyone need to explain this again? Right. Then let's go to the multiple sampling plan. So multiple sampling plan is an extension of the double sampling concept. Extension, right? Multiple sampling is an extension of double sampling. It involves the inspection of 1 to k successive samples as required to reach an ultimate decision. They have inspected k නම් පළවෙනි sampling ඉඳන් k කියන වෙනකන් යනවා. So it suggests k equals 7 is a good number. Multiple sample plan are usually presented in tabular form. Now the procedure commences with taken random sample of size n1 from large lot of size n and counting the number of defectives d1. Here the d1 less than a1, the lot is accepted. d1 greater than rejection, the lot is rejected. a1 greater than, so in between d1 lesser than a1 and greater than and this one, right? But in this situation, if subsequent samples are required, the first sample procedure is repeated sample by sample, repeated sample by sample. For each sample, the total number of defectives found at any stage, say stage I, is so likewise. This is compared with the acceptance number AI and the rejection number RI for that stage until a decision is made. Sometimes acceptance is not allowed in the early stage of multiple sampling. However, rejection can occur at any stage, right? You can see, now let's go to the other one. Now in this situation, multiple sampling plan, rejection can be happen at any stage. The double one is first and second we check and then we can reject it. Single one is පළවෙනි step එකේදී, second double sampling එකේදී two steps විතරක් යනවා. හැබැයි multiple sampling එකේදී any stage එකේදී whatever if the defects is going to happen, then it can be reject. මොකද ඒක multiple වෙවි යන්නේ, එකතු වෙවි යනවා. So you can see that summation එක නිසා එකතු වෙවි යන්නේ. එතකොට මේකෙදී rejection වෙන්න පුළුවන්. පළවෙනි එකේදී නෙවෙයි, දෙකේදීත් නෙවෙයි, but 3 4 5 එතන ඉස්සරහට යද්දි reject වෙන්න පුළුවන් chance එකක් යනවා. but එකේදී දෙක ගැන එච්චර ලොකු consider එකක් නැති වුණත් ඉස්සරහට යනකොට ඒක එකතු වෙවි ගොඩක් වෙනවා නම් reject the lot, right? So these things are especially applied in the production line is going on actually. Single sampling plan is not a production line, but for the final test take okay වෙනවා. But in the case of the other double and multiple, so it can be happen in the production line, right? Have you understood that point? චුට්ටක් හිමින් බලමු. එතකොට තේරෙයි. Now you can see here again that the rejection and acceptance and the SN is going on, N1 plus N2 again likewise. So it's going on. If make point එකේදී වෙන acceptance or rejection a lot, they can go forward, and this point එකේදී වෙන්න පුළුවන් N1 plus N2 වෙනකොට තව ටිකක් දුරට යන්න පුළුවන්, මෙතනදිත් reject accept වෙන්න පුළුවන්. So there's a multiple sampling plan. Rejection can be happen when the production is going on, because here that the what is the multiple sample plan, not it can be happen the first step, second step, third step likewise. So it's going on, not only at the beginning. So not only at the beginning, but කොයි වෙලාවෙ හරි වෙන්න පුළුවන්. අස්සලා සිංගල් එකේදී නම් එක සැරයි කරන්නේ, ඒක උනා හරි නෑ හරි ඒක හරි. මේකෙදි එහෙම නෙවෙයි, නැවත sample check වෙනවා. Right. So that is why in the multiple sampling plan එකේදී මේ rejection මේ දිගටම යනවා. D2 එක continue sampling යනවා. ඒකෙදි පල්ලෙහාට එනකොට මේකෙදි except මේ line එක මැද්ද යනවා නම් no problem. But if it is go to the rejection line, to the upper line, then definitely a lot will be rejection. මේ හරිය විතරක් පවතිනවා නම් ප්‍රශ්නයක් වෙන්නේ නැහැ all the time, right? If the line is going, the defects are so continuous sampling is going on. Therefore, here the D1 is SN or SN minus M1, here SN plus M2. That level එකේදී accept එක තියෙන්නේ පල්ලෙහා line එකට විතරක් යනවා නම් විතරයි. So accept වෙන්නේ. උඩ line එකට පැන්න ගමන් sample continue sampling යනවා. But උඩට පැන්නොත් it's having rejection. It's a rejection not only that sample. ඒ sample එක විතරක් නෙමෙයි reject වෙන්නේ, මුළු lot එකම reject වෙනවා. So I will give you another reading material for you to understand it much better. It is expensive, but the result is very clear. Near rejection line and above rejection line can be easily selected and rejected, right? So the near the rejection line and result is very clear. Above near rejection line and above rejection line can be easily selected and rejected. So the line එක ගාවට එනකම් මේගොල්ලෝ sampling කර යනවා, but එතනින් එහාට පැන්න ගමන්ම rejection වෙන්න පුළුවන්. ඒක හරි clear. මේකෙදි හැම sample එකක්ම analysis වෙනවා, right? In the multiple sampling situation, every sample, every product will be testing. But in the rejection අර පළවෙනි එකේදී single sample එකේදී එහෙම ඔක්කොම check කරන්නේ නැහැ. මේකෙදි හැම එකම check වෙනවා. For example, ඒක තමයි එතෙන්දී කියන්නේ. Errors in measurement, right? So now let's learn about what is the absolute error. In the main case, so here actually the question can be come for MCQs. Therefore, you have to clearly identify how we are going to calculate the absolute error. So absolute error is we call a capital E, and now you have calculated the median and mean. Now mean is actually 3 digits also used here because we are calculating error. Therefore, the whatever the final digit we have to use, we have to select for that means 19.78. No, not that 19.78. We have to take the 19.783 and the median 19.7. So what is that now? We know that the true value is 20, right? So the now have you remember I asked you to take notes about this one. Now true value is 20 and there is a 1 to the 20, nearest value is 20.1. මේ දෙක ගත්තාම in the 19.8 and 20.1 ගත්තාම, so out of these two values 20.1 is the most nearest value to the true value. The nearest value is 20.1. So we call it a xi. මේක තමයි ළඟම තියෙන nearest value එකට තමයි xi කියන්නේ. Data point to true value. xt කියන්නේ true value එක. දැන් true value එක මෙතන. ඊට පස්සේ මේ දෙක very important. x3 is a true value, xi is nearest data point to true value, and therefore absolute error will be calculation xi minus xt. කියන්නේ ළඟම තියෙන එකේ ඉඳන් ඒකෙන් අඩු වෙනවා minus වෙනවා true value එක. Accordingly 20.1 to 1 minus 20.0, and therefore you will get the plus 0.1. Therefore absolute error always having a mark plus or minus. So let's say now there is a 19 now true value is 20 and you think that there is a no 20.1. මේ 20.1 කියලා value එකක් තිබ්බේ නැහැ මෙතන. True value එක 20, then තියෙන්නේ 19.4, 19.5, 19.6, 19.8 and 20.3. එහෙමනම් then calculate the true value and කියලා chat එකට දාන්න බලන්න උත්තරේ. 20.1 කියලා value එකක් නැහැ. Forget this. Then what would be the absolute error of this sample? Right, good. Minus 0.2. Minus එක දාන්නම ඕනේ, right? Good. Now you got the idea. So when we calculate the absolute error එක මේක හරි ලේසි. ඉතින් මේකට MCQ එකකට යන විනාඩි එකමාරක් යන්නේ. But මේක so you have to keep your the theory principle එක ඔළුවේ තියාගන්න ඕනේ. True value එකට ළඟින්ම තියෙන value එකේ value එකෙන් true value එක minus වෙනවා, අඩු වෙනවා. ඒකෙන් අඩු වෙන්නේ. එතකොට plus minus එකක් ඇති වෙනවා. Then let's go to the relative error. ER, relative error is marking the symbol is ER. Relative error is a more useful quantity than error. Now because we are calculating in relatively, therefore E එකට වැඩි ER is the person ER is it's giving as a percentage, right? ඉස්සෙල්ලා දුන්නේ ඔයගලන්ට plus minus විතරයි. Now relative error එක always දෙන්නේ percentage එකක් විදියට. How we do is xi කියන්නේ nearest value minus true value divided by true value into 100%. Here xi is the data point closest to the mean value. Mean value, right? Here xi කියන්නේ mean value එකට. Here not the nearest the true value, right? Here මේක ලියාගන්න මෙතන mean value එකට කියලා, right? xi is the data point closest to the mean value. If so, mean value is 19.8. The mean value එක. What is the mean value of yours? Mean value is 19.783 නේද? Mean value is xi 19.783 minus 20 over divided by the true value into 100. What's the answer? නෑ හරි මේ උත්තරේ හරිනේ. මේ හදලා තියෙන විදිය. xi is the data point closest to the data point එක ගන්නෙ. mean value එක නෙමෙයි. data point closest to the mean value. 19.8 is correct. Closest to the mean value. Now, as I mentioned you earlier, from this data set, let's take this as a 20 point, let's remove the 20.1. මේ value එක remove කරන්න. 20.1 එක remove කරලා mean value එකක් calculate කරන්න බලන්න. Here, what you have to do is, you calculate the new mean value after removing 20.1 value. මේක අයින් කරලා new mean value එකක් create කරලා මට කියන්න what is the ER කියලා. Very good question, Shama. So, Shama ahanawa, madam, if there is 19.9 and 20.1 are available, what is the nearest value? Then what would be the nearest value with the quote? If so, nearest value එක තමයි වහන්නේ. But the question is, what would be the absolute error in such situation නේද? ශාම වහන්නේ මේ දෙක මෙහෙමත් දෙකක් තිබ්බොත් මොකද්ද nearest එක වෙන්නේ කියලා නේද? Right. In that situation, actually now the 20.1 එක ගත්තාම අපිට එනවා plus 0.1. 9 ගත්තොත් අපිට එනවා minus 0.1. Therefore, absolute error should be plus or minus 0.1. Have you got the point all? Shama, thank you for a question. And very, very important and very valuable question she asked. So then you are very clear about what is going on. එතකොට 20.1 එකක් ගන්න ඕනේ 19.9 උත් ගන්න ඕනේ if in that situation plus or minus 0.1. So right, thank you. And next question man kiwwe I asked you to remove the 20.1 value and get the new mean value and let me know if so for that set of data what would be the relative error. In that situation, you have to calculate new mean value and you have to take the closest value to the new mean value and calculate and give the answer. Again, the minus 1, right? What would be the new mean value if once you remove that 20.1? Someone can type 19.72. If it is 19.72 now, මෙතන තිබ්බේ 19.72 nearest එක වෙන්නේ 19.8 මද අපව 72. Yes, 72 again 19.8 minus 1. Good. Now you have got the point. මේ දෙකෙන් මේකෙන් පුංචි MCQ එකක් එහෙම දෙනවා. ඒක ඔයගොල්ලන්ට පොඩ්ඩක් අම්මලිකම යන්න, right? MCQ questions වලට සාමාන්‍යයෙන් මම දානවා. ඒකට ලකුණු ගන්න පුළුවන් ඔක්කොටම නේද, right? Good. Then let's go to the types of experimental errors, right? This is also very important. There are at least 2 types of experimental errors. Now, when I the absolute error, so I have mentioned about the plus or minus, no, absolute error, plus or minus 0, plus or minus 0.1 kilawani. Then later stage, when you are doing your research project, so that situation you have to calculate standard deviation, standard error කියලා අහනවානේ. ඒ දෙකේදී plus or minus එන්නේ ඇයි කියන එක ඔයගලන්ට මෙතනදී චුට්ටක් දැන් තේරෙන්න ඕනේ. මේ බේසික් අයිඩියා එකක්. මම හිතන්නේ ඊට වැඩි කරලා ඇති මේ වෙනකොට ස්ටැට් යටතේ. but you can get why that plus or minus coming here. Therefore plus or minus whatever the thing කියන්නේ mean value අපි ගන්න value එකේ ඉඳන් දෙපැත්තට සමාන දුරක් තමයි දෙපැත්තට හිටින්නේ. ඊට එකපාරක් පැත්තක් වැඩි නම් එක පැත්තක් අඩු හැම වෙන්නේ නැහැ. So it's a equal මේකේ උඩටත් යන එකයි මෙතනින් පල්ලෙහාට යන එකයි දෙකම එකම level එකට තමයි යන්නේ, right? You keeping that in your mind. Then come to the types of experimental errors. There are at least two types of experimental errors. The one is first one is random error, and second one is systematic error. Then what is a random error? Indeterminate errors. Random errors indeterminate. So we can't decide that these errors will be there randomly. It's happened randomly, therefore we call random errors. Causes for data to scatter around mean value is because the mean value is there, but once we get the mean value even, that some data points are there in the scattered around the mean value, and therefore it's reflected by precision. So you know what's the precision? Precision is the mean value is there and there is a different data points near the mean value is precision. If the precision is a very high precision, you know that all data points are very close to the mean value. But in the case of here in the random error, so if the mean value is there, the data points are very scattered. මෙතන එකක් තියෙනවා මෙතන එකක් තියෙනවා මෙහි තියෙනවා තැන් තැන් වල තියෙනවා නම් mean value එක වටදී. So we call it a random error. So it's reflected by precision. High precision නම් less scattering, low random error. Low precision නම් more scattering, high random error. So that is very easy, you can understand. So the high precision, less scattering, low random error. Low precision, more scattering, high random error. So it shows in your other picture. No, you have seen earlier that the red color circles and the dots are there. So by that you can understand this point. So systematic error. Do you want to go to that point? So keep in that high precision, less scattering, low random error. Let's go. Point එක. Right. Now you see. So this one, it says low precision. Now what is going on? The precision is the closeness of the measurement to the average value. So where is the average value is in the middle, right? Middle is the average value. So no, here all the data are scattered. So average value may be in the beginning. Low precision. So low precision means you can see all the data are scattered. තැන් තැන් වල තියෙන මේ data ටික scatter වෙලා. So ඒක නිසා මේකට කියනවා low precision කියලා. But here the mean value is also in this point and it's less scattering. Data ටික ඔක්කොම එක ළඟ තියෙන. ඒකද scatter වෙලා නැහැ. ඇතර ගිහිල්ලා නැහැ. Therefore we call that high precision. But here high accuracy එක මේක mean value එකට කිට්ටුවෙන් ඔක්කොම තියෙනවා. මම තියෙන true value එක true value එකට කිට්ටුවෙන් තියෙනවා, but low precision because scattered. Data scattered, therefore low precision. But here true value එකට කිට්ටුවෙන් තියෙනවා is high accuracy as well as high precision because all data points are there in a very close to each other. Therefore it is low scattered. Now you can understand that point, right? Now you can see that point. This high precision is a low random error, less scattering. Then low random error and high random error. Keep in your mind how that random errors are random error relationship with the precision. Systematic error have a definite value, have a assignable cause. So systematic error there is a definite value is there for the systematic error, and also have a assignable cause. So we can understand what would be the cause. Have some magnitudes for replicate measurement and same magnitude. So when we do the replicate measurements, If we know the true value, then the same magnitude that the error is there, they are always when we in the same error is there when we take the replicate measurements. These for bias in measurement technique, and therefore sometimes when we take the measurement technique, it leads for bias, because always we are getting same values. Same value means the magnitude of the error is same. Therefore, whatever the error we are going to get is really it's seems like more or less same. Therefore, we may think that there may be no error. Therefore, this is the correct one, correct data. We can see like that. We can think like that because of the systematic error. මොකද එකම magnitude එකෙන් තමයි replicate වෙන්නේ error එක. There are three types under the systematic error. There are three types of errors. First one is instrumental error. Second one is method error, and third one is personal error. මේක මම හිතන්නේ ඔයගලන්ට assignment එකේ කළා වගේ මට මතකයි. Mr. Sarah reading material එකේ, right? Now, if the instrumental error is there, then we are going to take the measurement of the so weight of the beakers or the weight of the crucibles අපි ගන්න යනවා. But if the machine electrical balance is not working and it gives a sometimes a 0.0001 addition value එකක් පෙන්නනවා නම් හැමතිස්සෙම we don't know, because instrument is giving error. Therefore, but we are going to measure it. But හැමතිස්සෙම එකම විදිහේ වැඩි වෙලා එන හින්දා අපි හිතනවා මේක හරි කියලා. Therefore, the one first type is the instrumental error. Instrumental error is continuously coming throughout the situation or throughout the way when we are going to take the measurement. කොච්චර වෙලා හරි අපි analytical balance එකෙන් මනිනවා නම් අපිට හැමතිස්සෙම මේ error systematic error එකක් තිබ්බොත් ඒක එනවා if it is instrumental error. And balance මේ හැම machine එකේම එම වෙන්න පුළුවන්. There may be instrumental error. Second one is the method error. Method එකේ වැරද්දක් තියෙනවා අපි දානවා නම් හැමතිස්සෙම බැද්දි ප්‍රමාණයක් හරි method එකේ temperature එක හත් කරනවා නම් වැඩිපුර, so if we have to heat the sample. හැමතිස්සෙම අපි ඒ රත් කරන එහෙම temperature එකට හත් කරපු නිසා අපි හිතමු volatile sign වෙනවා. ඒක method error එකක් වෙන්න පුළුවන්. For example, now let's see, now we are going to analyze the moisture content of the some මොනහරි නිකන් esters එහෙම තියෙන sample එකක් ගත්තොත් හොඳට සුවඳ ගහන sample එකක් ගන්නවා. So ඒකේ අර oleoresin සරම සමහර කරන්නේ, so those things can be, volatile things can be gone during when we heat the sample for 105 degrees. So then the method error is there. Then actual moisture content we are not getting, because the volatility කයින් වෙන ටිකත් අපි moisture content එක කියලා හිතලා අයින් කරනවා. ඒක method error එකක්. Then the personal error, සමහරවිට වගේ අත වේවුලන නම් සමහරවිට ළමයිට කෑ ගහනවා. So they at the class, so when they are going to measure the sample, weigh the sample, මේව අත shake වෙනවා. කරන්න මම I don't think that there are some people among you yourself regarding the personal errors. එයා වරද්දනවාමයි. එහෙම නැත්නම් so the personal error is coming at the burette reading එක ගන්නකොට ගොඩක් කලාට වරද්දනවා. හරියටම හැතියාගත්තේ නැත්නම් if you have not keep your eye in that level, then you can't take the burette reading correctly. Sometimes the pipette reading එක සමහර pipettes අපි අර ගන්න එකේදී bulb pipette එක නැත්නම් if it is not the bulb pipette, personal errors can be come. And also sometimes when you are putting the things to the beaker by using the pipette, සමහරක් අය ඉන්නවා අන්තිම පොයින්ට් එක වෙනකන් ගන්නෙ නෑ. ටිකක් ටට්ටක් ගාලා ගන්නවා අහකට. එතකොට අර last drop එක යන්නේ නෑ. Maybe 0.5 ml reduction can be there. එතකොට burette reading වෙනස් වෙනවා. ඔයගලන්ගේ reading වෙනස් වෙනවා. and burette එකේදීත් එහෙම ගොඩාක් එකපාර personal එක when you do the titration, you are not going to get the final drop එක දානවලදී drops 3-4 එක දිගට දානවා. Then the color change will be happen. Finally, you will take the burette reading will be different, not the actual one. Therefore, when you do the principles of food science ප්‍රශ්නෙනවා titration කොතන කළා වුණත් අර last drop එක දානකොට, so you have to slow down the burette again, drop by drop you have to put at the end ළඟට එනකොට නමත්තනම් පොඩි ගණන් දාන්න ඕනේ. So actually when the real technicians they do when they do analysis, then scientists ඒගොල්ලෝ last drop එකට යන්තම් පොඩි පොඩ්ඩක් අරගෙන so they put using the wash bottle they put it to the solvent or they make it go down by using the water. So then the burette reading is really correct. Especially the research assistant in the research institute, they do very careful analysis because they are the professional research assistants, right? So therefore the instrumental error, method error and personal errors ඉන්නේ අපේ අතින් වෙන වැරදි වලින් අඩුවෙන් මනිනවා එහෙම නැත්නම් so the some hardware him. So if we ask to take the crucible using the pair of tongue එහෙම ගන්න ගිහින් අතින් ගන්න. ඒතකොට අතේ තියෙන ඒවත් ගිහලා data වෙනස් වෙනවා. So likewise so many personal errors we do during our analysis. So therefore the systematic errors ඒතකොට එකම personal එකේ නම් මේ කරන්නේ technician මොන හරි වරද්ද කරනවා නම් so then personal errors are there throughout all data. So in your case even ඔගොල්ලොත් වරද්දනවා when you do your research project, if you do some wrong erroneous දේවල් කරනවා නම් කියන්නේ ඒක routinely, then the personal errors are there in your data, right? So systematic errors 3 types: instrumental error, method error, personal error. What is instrumental error? Caused by being different from original calibration. Volumes discharged by a burette or pipette is different from indicated graduation if not used in same temperature it is originally calibrated. So in some situation because the burettes and Celsius එකේදී නම් මේ calibration කරලා තියෙන්නේ, and when it come to the maybe 45 degrees වලදී වගේ නම් අපි කරන්නේ analysis එකක් නැත්නම් 40 degrees කියන උන්තරම ප්‍රශ්න කාලයක් නම් then sometimes small errors can be there. So volume discharged by a burette or pipette is different from indicated graduation if not used in the same temperature it is originally calibrated, right? So it can be happen මේ calibration කරනකොට so it should be standard one they have to use and නැත්නම් calibration so the අතන මෙතන කරලා so that can be happen. Caused by wearing off or residue build up rusting due to using. සමහරක් වෙලාවට so you have seen that the rusting that corrosion එක නිසා so හරි විදිහටම smoothly vernier caliper එකක් වගේ එකක් it cannot be due to rusting හරියට වෙන්නේ නැති වෙන්න පුළුවන්. So the wearing of so let's say now we are going to use the way කරන්න අපි ගන්නවා let's say the 0.005 milligram කියලා ගන්නකො 0.05 milligram පුංචි it's very small මේ චූටි පෙත්තක් වගේ එකක් තියෙනවා. අපිට දැකලා ඇති weighing box එක මම හිතන්නේ අපිට පාවිච්චි කරනවා කොහෙද හරි. I'm not sure, sometimes in the university කොහෙද පාවිච්චි. So weighing box are there in the labs, right? So if it is the wearing of අපි ගොඩාක් පාවිච්චි කරලා ඒක ටිකක් damage වෙලා හරි පොඩි කැලලක් හරි කැල්ලම් then the actual